Find the linear approximation for the function f of x equals the square root of 5x squared plus 5 at a equals negative 2. Then use the result to approximate f of negative 2.09 and f of negative 1.95. The linear approximation makes use of the function f of x, which is the square root of 5x squared plus 5, as well as its derivative. But before we take the derivative, let's rewrite this as a fractional exponent. It's 5x squared plus 5 to the first power second root 1/2 power. The derivative f prime of x, we'll start with the power rule, bring the power down, leave the inside alone, subtract 1 from the power, I will call that 2/2, and then multiply by the derivative of the inside. The derivative of 5x squared is 10x, the derivative of the 5 is a 0. The 10 can move out front with the 1/2. 10 times 1/2 is a 5. The x can also move out front, and the 5x squared plus 5 will be to the 1 minus 2 negative 1/2 power. Negative 1/2 power indicates that it can be moved to the denominator. The 5x will stay in the numerator. And the 5x squared plus 5 can move to the denominator to become a positive 1/2 power. Positive 1/2 power is the same thing as square root to the first power. So square root of 5x squared plus 5. The next thing to do is evaluate f at the a value of negative 2. So f of negative 2, which gives the square root of 5 times negative 2 squared plus 5, which is the square root of 5 times negative 2 squared is a positive 4 plus 5. Five times 4 is a 20 plus 5, and 20 plus 5 is 25. So we have the square root of 25, which comes out to 5. The next thing to do is evaluate f prime, also at the a value of negative 2, which will give 5 times negative 2 divided by the square root of 5 times negative 2 squared plus 5. In the numerator, 5 times negative 2 is negative 10. In the denominator, 5 times negative 2 squared is a 4 plus 5, giving negative 10 divided by the square root of 5 times 4 is a 20 plus a 5. So negative 10 over the square root of 25. The square root of 25 is a 5, so negative 10 over 5 comes out to negative 2. The formula for the linear approximation L of x is f of a plus f prime of a times x minus a. Specific to this problem, a is a negative 2, so this comes out to f of negative 2 plus f prime of negative 2 times x minus a negative 2. Or f of negative 2 plus f prime of negative 2, and then x minus a negative 2 is the same thing as x plus 2. We have values for f of negative 2, it's a 5, and f prime of negative 2, it's a negative 2. Those can now go into place into the linear approximation. So L of x is now equal to f of negative 2, which is a 5, plus f prime of negative 2, which is a negative 2, times x plus 2. This can be simplified by distributing the negative 2 in here, giving 5 minus 2x minus 4. And the constants can be added together, so 5 minus 4 is a 1, and then minus 2x. And there's the linear approximation. The next thing to do is approximate f of negative 2.09, and that's approximately equal to the linearization evaluated at negative 2.09. Numerically, it's a little bit easier to use the original form for L of x, not the simplified form, so we will plug into that version of it. 5 minus 2 times negative 2.09 plus 2, which gives 5 minus 2 times negative 2.09 plus 2 is negative 0.09. And this comes out to 5. Negative 2 times negative 0.09 comes out to a positive 0.18. And add that to 5, and that comes out to 5.18. Next, we will approximate f of negative 1.95. And this will be approximately equal to L at negative 1.95. Again, using the same form, we'll come out to 5 minus 2 times negative 1.95 plus 2, which will give 5 minus 2 times negative 1.95 plus 2 is a positive 0.05, which will give 5 minus 2 times 0.05 is negative 0.10. And 5 minus 0.10 will come out to 4.9.